Yes.
Are we going to have another quiz and then a test?
I'll have to check. I think I might have another quiz for you, but I'll know like next week. Okay, equivalent expressions. Remember, an expression is when you have a bunch of terms but no equal sign. And the word equivalent, you have this in your notes package. Just take it out. We're on page 29. And equivalent means that things are the same. So the way that we find out if two things are the same is we could simplify both of them. And if both of them simplify to the same thing, we would say they're equivalent. So 4x minus x, those are like terms. 6 and 2 are like terms. I can simplify this to be 3x plus 4. So we would say, yes, they are equivalent. And you've dealt with things that are equivalent before. For example, with fractions. Can you tell me something that is equivalent to 1/2 but does not look like 1/2? What's that? 0.5. Those are equal to each other but don't look like each other. Is there anything else that would equal those but not look like those? Oh, close. 0.49 repeated. Anything else? Could you write a, yes? 50%. Love it. Could anybody write another fraction? 50 over 100. So in math, we have lots of different things that show the same thing. I thought someone would jokingly, I was waiting for like, 1/2, 0.5, 50%, 50 out of 100, my English mark, blah, blah. Whoa, too much information. Okay. So we say that two expressions are equivalent. Here we can highlight that as a key word if they simplify to the same thing. So your job, I wrote one here that is equal to 3x minus 9. You have to write two more. Anything that would be equal to 3x minus 9. So you write something that when it simplifies, where's your notes today? Your note package. Okay, yeah.
I'm trying to get these from Middle East back. It's stuck here, and I can't turn to do what I need to do.
Okay, do you want it apart again to analyze it again?
Because I can visualize what it needs. I just don't know how to get it there now.
Should we give
Wait, would that
in
work?
30 seconds?
Oh, yeah?
Okay, you try. Oh!
Oh, come on.
Almost like you said it out.
Thanks for making me look bad.
Yeah.
Wait.
You just made Mr. Shirk feel shame.
Would this be right?
Because this simplifies to 3. Yes, that's a nice one. Oh, I like it. I'm going to put that one up. We got one.
Yeah.
I write that one down. 6x squared divided by 2x minus 9. I like it. Okay, I'm going to come around, see what we got. You got one? Ooh, I like it. I like it. We had 2x plus x plus 3 squared. Had a fancy squared thing in there.
No, be negative.
Oh, yeah, it was a minus. Sorry. Oh, thank you for noticing. The person had it right. I just copied it down wrong. Minus 9 squared. All right, that's, get another one here. Ooh, good. We got some adding and subtracting. We got 4x minus 19 plus 10, or if you might have had them 10 minus 19. Good. So can you see that there would be an infinite amount of right answers that you could do? Okay? And so in mathematics, right, in mathematics, we always want to write something simplified. And I think that's part of the teachers going, if I don't ask you to simplify something, then there would be an infinite amount of right answers I would have to check, which would be a little frustrating. So
Every single answer you can find.
we go, if everybody simplifies it, then we're talking about the same thing. And this is important not only for math, but in many things in real life, okay? When you're communicating with someone from a different business, you want to be talking about the same kind of things. So for a long time, there was problems with measurements. It's like people were using meters, but one person's meter was different than another person's meter. Okay? And even earlier before that, before meters existed, what was the main measurement? Was like a foot. Do you know how big a foot was? Right? It changed. It depended on who was king. They used the king's foot. So the king's foot got bigger or smaller, then they're like, oh, we have to change all our measurements again. So you had this idea that you wanted to have things standardized so that when you were talking about a foot, it was the same foot as everybody else's foot. Okay. You got it now?
Because this is already stuff, right?
Mm-hmm.
That's the tough part. It's one act of.
He had it. He lost it. Good. Everybody's got, people have answers for this next one? 3 equivalent expressions to this one. I'm going to put 2 of them up. One of them's going to be right, one of them's going to be wrong. And I want you to tell me which one's right, which one's wrong. Okay, I'm going to do one in orange. Don't write these down unless they're right. And I'm going to do one in purple. And you tell me which one is equivalent and which one is not. The one on the board. What you got? Yes, yes.
The
orange one's right, the purple one's wrong.
Oh.
No.
Ooh, I like it. We got an argument happening.
No. Wait. X times x is x squared. Plus 2 plus negative 2 is negative 4.
Yeah, but you told you I could find it.
Oh.
Are the X's the same?
The x's are, when you use an x,
X is different than
in an equation, when you're using a variable, that variable is always the same all the way through.
What?
Hmm? Okay.
No, X's are always the same.
Yeah, like if x is 3, it would be 3 for all of the x's. But I'm asking which one of those matches up with x squared minus 4. And there seems to be an argument. Some people like the orange one. Some people like the purple one. Or do they both work? Or do they both not work? Oh my goodness.
They don't work. Wait. Times minus 4.
I can do that now. I can make like 5 my face with my mask because it's allowed.
No, it doesn't work. None of them work. That's what I was like, wait.
Ooh.
Yeah, I was thinking about that and I'm like, yeah, that's not right.
All right. Well, if I FOIL this one, it happens to be x squared minus 3x minus 4 if I simplify. And if I FOIL this one, it happens to be x squared minus 4. This one is good. This one is bad.
What? No. I already said purple. Yep.
X times x is x squared. X times minus 2, x squared, negative 2x. Good. 2 times x is plus 2x. Oh, and then 2 times negative 2 minus 4. Mm-hmm. This is technically something famous that comes up. 2 times 2 is 4.
Because the two x's cancel out together. So it says x squared.
Minus 2x plus 2x minus 4. This is something famous that comes up in grade 10 called a difference of squares, because this is a square and 4 is 2 times 2 is a square. We learned that what a perfect square was earlier, and it happens to equal x plus 2, x minus 2. Because when you FOIL it out, the outside and the inside cancel each other out because they're like terms, but one is a 2x and one is a minus 2x. Here is another difference of squares. What do you think it's equal to? Yes. Here's another difference of squares. What do you think it's equal to? Here's another difference of squares. What do you think it's equal to? Perfect. Right? Here's another difference of squares. What do you think it's equal to? Oh, how crazy do you want me to go? Like super crazy? You ready? Yeah? Okay. How hard should we go, Mr. Shirk?
Not much harder, please. Don't know.
One number. Pick an even number. 8. Okay, what do you think this one's equal to? I'll make it, maybe I have to make it a little wider because it'll be big. 8, good. Yes. Ooh. 8xa again, and then minus. Okay. If anybody asks, you don't know this, you're like, oh, do you learn that in grade 10? Cool. Okay.
That you would struggle with that next year, probably.
That's grade 10. That's grade 10 and is a pattern on something called difference of squares. Now I'm going to tell you these aren't equivalent. How would you show that something isn't equivalent? You can't just say, just because I know.
Go like this.
Yeah, but no, but you can't just, like, how do you prove that those aren't equal? Because this is 2x, and that's x squared. Why aren't they equal? Is it?
Well, it can be small, it can be big.
Oh.
Because they're not the same.
If two things are the same, they will work for any number. If two things are not the same, you should be able to find a number that you could put in for x that makes it not work. Okay, if x equals 1, then 2x is equal to 2 times 1, which is 2. And x squared would equal to 1 squared, which is equal to 1. They're not the same. If you can find only one number that works, like you could pick 3, Which number shouldn't you pick? If you wanted to show they're not equal, you shouldn't pick 2. Because 2 times 2 is 4. And 2 squared is 4. So it wouldn't work there. But you just need to find one number that shows that they're not the same. Then you could show that they are not equivalent. Are these equivalent? Okay. If you want to say yes, then you have to simplify them to show that they're the same. If you want to say no, you have to find an x that you plug in that doesn't work. It's not the same. So what number are you putting in? 4. What is 4 minus 3? 1. Times the negative would be? Negative 1. What is 3 minus 4? Oh, wait, those ones work. So maybe you have to try a different number. Or, okay, but then we go to Haley and she said, no, I'm going to try simplifying. Which one could you simplify? The first one, what would you do? Distribute. Awesome. Got to use those words. You distribute the negative. A negative times an x is negative x, and a negative times a negative 3 is plus 3. Okay, they still look a little bit different. Are they close enough? Okay. There's an important thing in math. Okay. I'm going to tell you that 27 plus 81 is 108. Okay. You got that? 27 plus 81 is 108. What's 81 plus 27? 108. Did you know that? When did you learn that? Because you didn't learn, no, you didn't learn it in grade 1. Because I've done it with, see, if you're a math teacher and your kids grow up, you do all sorts of experiments on them, right? For example, when they're in grade 1, you ask them, what's 8 plus 5? This takes a while in grade 1 because you run out of fingers. It's a little bit hard. So you do 8 plus 5. 5 minutes later, they're like, 13. And then you go, okay, what's 5 plus 8? Oh, and it takes them another 5 minutes because in grade 1, you don't know that 5 plus 8 and 8 plus 5 is exactly the same thing, okay? A little bit later, you're like, well, I have 8 of one thing and 5, and I'm adding. It doesn't matter where they are, right? I still have the same amount. So negative x plus 3 is the same as 3 minus x. They are the same. When does order matter? Subtracting it does, right? Because 5 minus 8 isn't the same as 8 minus 5. Dividing would be the same because 8 divided by 2 is not the same as 2 divided by 8. But multiplying? That's okay. That's okay if you flip them around. So it's interesting. And some of these things you think you've known forever, but you actually learned them somewhere along the way. Okay, I've got a sheet for you. Mr. Shirks, go. Oh, he's busy. No.
Did you get it?
No, I had it, now it's gone.
Okay, on this sheet, after you've answered a question, find someone who's also answered that question, compare your answers. If you get different answers, I want to hear some good arguments.